Welcome to Module 4, Lesson 16. So, still kind of going off the same idea here. It's the kind of understanding that area can look different, but still have the same area. We've talked about this in the past, how a 1 by 10 will have the same area of a 2 by 5. They will look different, but they have the same area. So going from that, that is kind of where we're going to now, and understanding that you can have weird looking shapes like the one right here and still have it equal to the area of something else. So let's go ahead and just practice solving this one right behind me, and then we'll go ahead and see if we can find a shape that has a similar area to it. So right here, once again, I have an odd looking shape. In order to find the area of this, I will go ahead and do an imaginary line cutting that off right there. Now I have two smaller ones. I have rectangle A and rectangle B. So rectangle A will be 4 times something, and B will be, look at that, we already have both of its side lengths. 2 and 1 will be 2 times 1. And we already know that will be 2. And let's say that these are all feet, so just go ahead and say it's 2 square feet. Now we do have to find this angle, this length right here. And just kind of going off of things before, if I know that this is 2, 2 and what equal 4? So that would be 2. So 4 times 2 would be 8 square feet. Add them together real quick, that would get you 10 square feet. And now the question is, can I create a shape that has the same area as this? Now, it's been a while since we've done this, so as a reminder, basically all I'm saying is what times what equals 10 square feet. It can be a rectangle. We don't have to create something weird and crazy like this. Trust me, that's a little complicated. I'm not going to ask you to do that. Just give me a rectangle that has the same area as it. Which means we just need to go back to your previous strategy you have. Go through a whole bunch of different letters, I got it right the first time, numbers, to determine if it goes into 10 or not. Well, does 1 go into 10? 1 works. Does 2? Yes. Does 3? Goes 3, 6, 9, 12. Does not work. 4, 4, 8, 12. Does not work. 5, 5, 10. 5 works. Does 6, 6, 12. No. 7, 7, 14. No. 8, 16. No. 9, 18. No. 10 and 10 works. So, once again, 1 and 10 can go together, and 2 and 5 can go together. So you have 2 answers you could put here. You can make a shape that is a 1 by 10 or a shape that's a 2 by 5. Does it look different? Yes, very much so, but it has the same area. Now, that kind of is the entirety of this. There's not a whole much more we can go into it because at this point, it's much more practice. You're doing the same thing now, just practicing over and over and over and over and over, doing the best that you can to ensure that you are getting these things done correctly. Once again, biggest thing I'll remind you is that this length adjacent from a complete side, from here all the way down to this invisible line here, that entire thing is 4. That is going to be the biggest thing you need to remember. If that equals 4, 2 and what equals 4? 2 plus 2 equals 4. Or you can just say 4 minus 2 equals what? 2. But once again, that is kind of the biggest thing. This is going to be a relatively short one because there's not a whole lot more to go in depth on. This lesson is a lot more about getting that practice in. So, if you're still struggling a little bit, go back, watch the previous lessons, get in the Zern. Zern does a phenomenal job of additional practice. So if you're still not sure, I highly recommend go back and do that lesson again. It is extremely helpful. Or the last couple of ones. So anyways, short lesson, but just kind of wanted to give you a quick reminder on how this stuff works so that when you go right into questions here in a little bit, you'll know what to do. Anyways, hope you guys got this, and I hope you guys have a great rest of your day.